Okay, so we're going to talk about e-substitution, specifically how we use it to solve integrals when the pieces line up perfectly. So u-sub is basically a way to simplify a messy looking integral where we see compositions of functions like a big power or really more complex inside. You can let that inner part be u, and let the rest of the function usually falls into place. So you have your steps. So the first thing you want to do, you want to pick u, and then you want to find u, check the integral, rewrite in terms of x, integrate, and substitute u back in. Now this sounds a little bit complicated, but once you actually do it, it becomes more simple once you practice. So, for example, we're going to have this equation, 2x plus 1 plus 3 times dx. So, step 1, remember, pick u. So what's our u? U is remember what's inside of the parentheses, what's inside of the square root. So in this case, we have what's inside of the parentheses. So it's just going to be, and then we're also going to do du. Well, we're getting too ahead of ourselves, but u right now is just going to be 2x plus 1. And then we want to step 2, take the derivative. So make this du 2. And that's where we are. So now we're chilling, right? So it's du, and then it's going to be dx. So we have 2x right there in the integral. Now we can rewrite the entire integral because it's matching up with our original function, which is 2 right here. I forgot, sorry. It was supposed to be parentheses 2x plus 1, but whatever. Yeah, so now we want to rewrite the integral. I'm rewriting it because it already matches up with it. So our u is to the third, and then du. This is going to transform to u to the fourth, and then fourth bottom, and then plus c. However, we need to substitute our original function, which was 2x plus 1 to the fourth, divided by 4 plus c. So let's see if we can get a little bit more complicated, and we can. So let's try this. Let's do 8x divided by x squared plus 4 squared dx. So step 1, what's inside of the parentheses in the denominator? That's going to be our u. So this is our u, guys. It's going to be x squared plus 4. And then, again, you got to take the derivative of u. Okay, so that means that's just going to be u equals d dx. So again, we're thinking about if it matches or not. So unfortunately, 2x does not match with 8x. So, next row. Wait, no, I'm lying. Yeah, it doesn't match with 8x. I'm sorry, guys. I forgot. I rewrote. Wait. Yeah, it doesn't match. Sorry, guys. It doesn't match. So we have 8x in the integral. So we have 8x dx in the integral, which is exactly 4 times du. So then it'll just be 8x dx, which is going to equal 4 times u dual du. And so we can rewrite this again. So we can do this 8x x squared plus 4 squared dx over here. And then we could do this 4 u squared du, which equals parentheses, don't kill me, 4 u squared du. And now we're going to integrate, make our lives so much happier and easier. We can do u minus 1, because remember, it's the antiderivative, and then times by 4 plus c, and then we're just going to have minus 4 u plus c, substitute it back in, because that's where our u is. We're just going to have minus 4 2x. Oops. 2x. X squared plus 4. Plus 1. Yeah, I tried my best to explain that, but I just, so okay, we're gonna do one with the square root. So, what have we done so far? Cool, cute. This is fun. So example 2. So we can do this. 5x squared plus 3 times 10x dx. So step 1, pick out our u, which is inside the square root. So let u be 5x squared plus 3. And then now we're just going to take the derivative, which is du times dx. So it's just 10x dx. So luckily this matches up. This is when they say when they match. They match. So that means this can be replaced with du. So we can rewrite it now. So the integral square, remember this is u, you got replaced, and we have du. This equals du. It's just the exact same thing, so we don't need to go through the entire process. Yeah, so du, and then we're gonna do it again. Remember, square root can turn into 1/2 du. That's just going to turn into 2/3 u, and then 3 to the second plus c. Substitute it back. It's like once you start doing it kind of becomes a little bit more simple over time. And then, yeah, here we are. Now let's move on to the next topic.